Thanks for coming to my session. I'm Lynn Langit, and we're going to talk about my journey with visualizing cloud system. This image has significance to this talk that we'll explore through the talk and summarize at the end. Thank you for coming, by the way, late in this conference, and thanks to the organizers for having me. It's my first time at KanDDDinsky. I very much enjoyed it, very much learned from the community, and if I were to summarize this conference, I would say that I commend the community in the focus on communication, which I think is critical to the success of technical endeavors. Talking about visualization. So why do system pictures matter? I'm an independent cloud architect. I lead teams globally in building all kinds of different solutions from the prototyping stage all the way through to production. In this talk, I'm going to focus on learnings that I've had and questions that I have in the area of communication, particularly in the visual realm. So I'm going to start with a simpler use case, or more commonly understood, an area that I'd been working on in the beginning of my career, not as much now, but I think everybody in the room has probably made a web application. So it kind of gives us a warm-up. So we're going to first, rather than jump directly into the system views, we're going to look at service views, because particularly in these days of cloud-native architectures, serverless architectures, appropriate selection of services becomes even more critical in my experience. So we're all builders. Here's a list of requirements. Build this. Minimize the cost. It's the primary requirement. The service cost. It's going to be on the cloud. Use a public cloud. Design using microservices patterns, process file-based data, and expose the result to authenticated web client. Very kind of a simple use case, something we've probably already done. This is a simulated whiteboard, but there are a whole bunch of visual assumptions in this diagram that we'll be exploring. So in many times in my work as an architect, particularly with startups, that list of requirements is seen as enough to get started. So then this kind of a drawing will emerge quickly, and then we'll get right to coding, right? That's what we do. We get right to coding because we're builders. So one of the assumptions that I have been thinking about and seeing the results of and want to challenge our thinking is, what is actually code? In any sort of a conference with builders, I always feel inauthentic if I don't show some kind of code. So it was quite challenging in this talk to think about how I could maintain my authenticity as a builder, as a developer, but to show a bunch of pictures, which is really a starting assumption for us to think about. Why don't we value pictures? Why do we start our value at the level of words? Even sometimes going directly to code, not using our native spoken languages. And in case you're wondering, this code, if you're not familiar, is CloudFormation YAML code from Amazon. That's configuration code, which is yet another assumption I want to challenge. Because in my world of microservices, the developer teams that I work with very frequently either aren't even interested in this or relegate this to the new person or don't do it at all because it's not seen as having the same value as the business logic code, much less picturing it, which has led to all kinds of problems in the customers that I've worked with. So we are building a website. So we want to get some sort of reference architecture. And this is a canonical use case because in my world in the United States, Amazon is very dominant. So you start with Amazon. There's quite a bit of visual information being conveyed really quickly here, as opposed to our whiteboard. We have now our 3 tiers. We have our API tier, we have our compute tier, and we have our data tier. However, I've highlighted some really important subtle differences than our original pure microservices architecture, API gateway, Lambda, and persistence store. And in this particular example, which I pulled from Amazon's documentation, they're showing stateful compute in a couple of cases. They're showing transactional data persistence. These subtle differences matter at the level of visualization. Another way to look at this is to look beyond what is in my world the most dominant vendor. You may not be even familiar with what this reference architecture is. I don't know what kind of presence this vendor has here, but this is a vendor that's having more and more impact with my APAC customers. This is an Alibaba reference architecture. It's the same or similar architecture. Notice how much harder you have to work visually to comprehend it. Why is that? There's no difference in the shape of the boxes. There's no difference in the colors. There's the layout is not organized in a sort of linear way. And you probably are because you're very detailed people, were you able to spot these differences as quickly as you were able to spot the differences from the canonical architecture being these here? Probably not, right? So I always like to pick on Google, even though I'm a great fan of the Google Cloud, and I'm a big user. When I was solving this particular problem, building this website, it was quite a long time ago, it was 10 years ago, and Google at that time had no icons, had no reference architecture. And I actually provide feedback to all the big cloud vendors from a partner standpoint. And I told Google that I didn't want to draw for clients Google architectures using Amazon icons. Could they please address this problem? And we're all kind of laughing, right? But this shows a greater problem in our industry of the lack of value placed on visual communication. So in fact, kind of ironically, this was 2009, it's for my nonprofit simple website. We wanted to pay no more than $5 a month. We built it, and we built it on Google. Because the first serverless services were not Lambda, they were App Engine. App Engine included a NoSQL database, sort of a pre-DynamoDB, and allowed us to fulfill that requirement. So what's the visual aspect or lesson here? Yes, we were able to build this. However, the development time took weeks instead of days because we had no patterns. We had no documentation. We had no nothing. But we were super motivated because we were a nonprofit. But is this the kind of situation that's optimal for building? Don't think so. So speaking of Amazon, this is a screen cap from their current list of services in the North America region. In addition to being an architect, I'm also an educator. I have 30 courses on LinkedIn Learning, lynda.com. I have over 4 million views. So I get a lot of interaction with builders because they write questions to me, especially people coming new into cloud. And the most common question is, you probably think of it, where do I start? What do I use? How do I build cloud natively? How do I get those economies of scale? What do I do? So what I have found in this work in education, both this broad reach and with specific customers, is as I'm helping customers to move to cloud native, cloud service architectures, I have a pre-architectural step, which is helping them to understand visually what services are available, because this is not comprehensible. It is interesting, however, Amazon, of all the cloud vendors, has paid the most attention over time to providing usable visual references for their services. And as you'll see in this talk, I have several examples of something that maybe you hadn't considered before. I hadn't before I really started thinking about this, have resulted in customer success. So, by the way, I love Berlin. I'm back in Berlin for the second time. I was here last year for GoTo, and your architecture is stunning. So you should know where this is if you're from Berlin. So very, very often when I am working with a new group and talking about how to visualize cloud native services, if the group is very developer focused, this is what they want to talk about. And again, you can see, pictured like this, what the limitation is, particularly in contrast to that service dashboard. So when I think about a cloud-native architecture, again, I have it shown in there. It's pretty close to here where this is. This is kind of what I think about. I'm going to think about the compute layer, which is often Lambda. I'm going to think about the data layer, which could be serverless, NoSQL. or S3. But I'm also going to think about, are security services available so I don't have to build them? So this is Cognito, and this is certificates. Now, I'm not saying you should always just consume the services that are there. But what I am saying is you should be aware of what's there so you can consider the amount of effort it would take to build what is needed for your business versus what's available. I've had many situations, particularly with startups in Southern California where I used to live, where they were just flush with cash, and they would just hire lots of developers, and they would build things that were already available. This is particularly problematic with machine learning. This particular architecture was one that I worked with an enterprise company. This is IoT. We were one of the first users of AWS IoT services about 4 years ago. We took a project that was trying to be built in-house. It was a complete failure, so the enterprise had a lot of motivation to try something new because they had 10 developers for 4 years and it was produced nothing. And so we moved to a cloud architecture, and that factors into the story. So I like to joke that in all of visualization, of course, Amazon, being Amazon, does pay great attention to the detail. This is the most important visualization that I've seen. Why? How many times have we seen stories that are incredibly embarrassing to our industry about customer information being available through public S3 buckets? If you follow this, Amazon has tried 4 different ways to tell us, hey, look, it's public. Look, it's public. Do you really want to do this? It's public. It's public. I think this one is good. I don't know. So at the service level, having appropriate visualizations helps us make intelligent decisions about build versus buy. And from a really practical point, I believe Amazon's focus on this has been a critical factor in their adoption. And the reverse case, although Google Cloud Platform has, in my area, the cheapest, the most performant services, their lack of focus on it has been a significant hindrance in particularly enterprise adoption. I've literally had customers, enterprise customers, say, if you can't draw me a diagram, if I can't see it, I'm not buying it. All right, now let's talk about systems. And we're going to talk more about that IoT case. So as the lead architect on the IoT case that I talked about, happy news, I'll get the end case first. We had the death march I came into that was there for 4 years. It was a .NET shop, C#, all Visual Studio. We shipped in 10 months. We shipped on Amazon, their first cloud thing, on Node, IoT platform using combination of servers and serverless. We did it. I believe visualization was a key to our success. And that's one of the reasons I wanted to include it in the talk. So what is the aspect of visualization that was particular to that project? It was this idea of system views. And I've actually heard this in some of the other talks that I've listened to. So I have a mind map. Let's see if I can get out to it, that I've linked in here that kind of details this a bit more, but I just summarized it. Because I was really the keeper at this particular project. It's a very famous group. It's the group at Hunter in San Diego. You probably know, one of the first mob programming groups. And I was there when they went from 1 mob to 6 mobs. It's one of the reasons I took this contract, because I wanted to be part of that transformation. And it was really interesting in working with this project to be the visual guardian. So at the design and development stage, we're all familiar with these tasks that different roles would do. What's interesting, and again, I prepared this specifically for you guys, so you'll have to let me know if this is useful or not. I don't know if you can see it properly. But these are the artifacts. So like when you're having an MVP, like you'd have a document, you have a wall of sticky notes. If you have a budget, you have a spreadsheet. If you have a selection of technologies, you have a diagram. The question is, how do we go across these domains and make all these artifacts consumable? And again, I'm certainly not the only person to talk about this here, but maybe this is just a slightly different perspective. How do we have a security diagram that's consumable and understandable both visually and with the appropriate level of annotation to have effective communication? In terms of our deployments, this was such a critical one for us because we were building a CI/CD pipeline. So kind of the all-up of this is, and what we really worked on, is how do we visualize across the system? And I think because we focused on this, and we talked about this, and we iterated on this, I account for it as one of the key reasons we were successful. And I just wanted to share, because like I said, we went from 4 years of not success to 10 months of success, which was pretty dramatic. So one of the areas in particular that we were challenged in this particular case was this idea of the CI/CD pipeline. We had the goal of deploying daily, and this pipeline happens to use cloud-native services, which we didn't use in the case, but I'm getting a lot of questions about this from my customers, because you now have these serverless services that are associated to the various clouds. Because we didn't have the picture of the pipeline, I believe it took us longer. It's just that simple. It seems obvious in hindsight, but I like to share the pain that I've gone through so maybe others won't or have less pain. We didn't draw the picture of the CI/CD pipeline for a couple weeks in. And once we did, we proceeded more quickly. So thinking about system views, a person whose work I very much admire is Adrian Cockcroft. I don't know if he's ever been here. I'm sure a lot of you know about his work. This is a project that's he did. It's open source. There's the link. It's Simian Viz, between his time at Netflix and Amazon. The idea is that you have an operational system view of all the nodes of the system, but you can do scenarios on it, chaos engineering scenarios. So the implementation actually isn't that important to my discussion. It's more the idea of different system views. Because again, we as mostly builders tend to have a bias towards which view? The developer view. So the bias I want to challenge is, how can we as an industry think about views or customization of views of our systems for different roles that have a visual basis? So, okay, that's kind of the background to this. The real reason that I've come here to Berlin and worked on this talk is I had a big shift in perspective 3 years ago, in really fundamentally. As you can tell by my accent and what I said, I'm American. But I spent a bunch of time in Australia. And I was there working on data pipelines. Now, in addition to web apps and IoT apps, actually more primarily, I work on data pipelines for fintech, New York fintech, London fintech, social media stuff in California, a lot of data pipelines. I had started to work in bioinformatics because San Diego is a big bioinformatics community. I had a couple clients, interesting startups, and irregardless of the human aspect, as a data pipeline architect, this is really a fascinating space. If you're not working in this, the amount of data that is becoming available because of the decreasing price of sequencing is something I've never seen in my 15 years of working in the industry. In the field, as I've said here, it is suggested that by 2050, half of the human population will be sequenced. And as I'm coming to learn, it's not just a baseline sequence, which is big enough, 3 billion letters. It's sequencing of our microbiome, which is the organisms that live inside of us. So it is an amount of data we have never seen before. It dwarfs the social media data. So I started a project with Google that took me to Australia. And I was working on configuration. And it was an interesting time because I was just intellectually interested in the problem, and then two things happened. The first thing was my then 17-year-old daughter got accepted to go to Stanford. She wanted to work in bioinformatics, and she took cancer biology at 17 at Stanford. And she came home after the summer, and she said, "Mom, these people are not using the cloud. They don't know how to use Docker. They don't know configuration." I was like, "You got to be kidding me, man. You're at Stanford." So then I did a little bit of research into this, and I read several papers, but one paper in particular was really stuck with me. Of that particular paper, of the published research in genomic sequencing for moving towards personalized cancer treatment, 75% of what was published was not usable because the configuration was not reproducible. And I was stunned. I said, this is clearly an opportunity. And then something else happened. My best friend got cancer. And she almost died. She did not die, but her name is Terry. She was not able to participate in any sort of personalized treatment. So she had the most brutal treatment, almost inhumane treatment. And it basically changed my motivation for my work for the rest of my life, because I'm no longer going to work on what I call the bullshit stuff, the California ad, stuff. I'm going to work on this. Now, it was quite daunting because I don't have a computer science degree. I'm a self-taught programmer. I don't have a bioinformatics degree, but I do have motivation, and I don't watch television, which helps. So I was in Australia at the conference, and there was this reference architecture that had been published on the Amazon blog from this group in Australia called CSIRO Bioinformatics, Commonwealth for Scientific and Industrial Research Organization, like the National Science Foundation. There are some people from their team that attended an AWS summit in Australia, saw cloud-native architecture. This is the key point, a usable diagram. They had a problem that would lend itself to burstable compute. It was basically searching the results of genomic variants so they could find where to use CRISPR. And they built this. So the first visual lesson is because Amazon paid attention to providing usable visual reference architectures, people who were not computer scientists could build something usable. They built this in less than a month. So they made me work for my money. I said, I want to come and learn about this. They said, great. We have a little problem with it. It doesn't always perform well. You're Miss Cloud Architect. What can you do? I said, oh, okay, I'm on now. I have to do this. All right, so I said, in these types of systems where they're all cloud native, you can't SSH into the machines, or what are you doing with the logs? And they said, oh, we don't really understand. And I said, aha. So within one day, we were able to speed this up by 80%. And how did we do that? Another visualization win. I happened to get lucky. X-Ray, which is Amazon's log reader, had just been released. They hadn't heard about it. We turned it on. One of the circles went red. Oh, there's the problem. Let's rewrite it. Boom. Okay? Just that simple. 2 visualization wins. Very significant. So they said, okay, we have a more difficult problem for you. I said, all right. So this is their requirements. Use a public cloud to minimize cost. Create a reproducible design because we want to publish on this. Use a modular design. Process file-based data. Expose the result to authenticated web clients. And this is the whiteboard, basically, of your classic data pipeline. And again, dive into code. The more observant of you late in the conference will see that this is not CloudFormation, but it is Terraform, which is configuration code that is applicable to multi-cloud, because that is something they wanted us to do. Terraform features into the story, but not necessarily in a positive way. So just to get a bit more about the particular problem, it was a very gnarly problem. They had, because of their business problem, which was to analyze very, very wide machine learning models, they had written a custom version of random forests in Scala, which was a language that none of my team knew. Anyway, and they had an on-premise shared Hadoop Spark cluster, and each time to run it, it took 500 hours. So they said, we got it working, but gosh, there must be something better you can do. And I said, all right, let's work on this. So there is some happy news to the story. We did get it to 10 minutes. We did, which is non-trivial, and running on the cloud, running on multiple clouds, actually. But it wasn't a straight path. Visualization came into play in that when we first started, this was 3 years ago, their team has doubled or tripled in size now because of their successful projects. They had half a DevOps person, basically, and the only experience they had with cloud So new paradigm in development was that previous thing I showed you. So a common pattern is to create an intermediate step when you're moving to cloud. So we did sort of the classic lift and shift. I can't tell you how many times I drew this diagram to get them to be able to replicate this, probably about 7 times, with an emphasis on flow and minimum components and minimum documentation. The good news is it worked. Went out to Australia. We were able to transfer this knowledge to the team. They were able to stop clicking on the console, you know what I'm saying here, and use CloudFormation template so that it could be replicatable. And it worked within hours. So we were pretty happy with ourselves, me and my team. So we did what we all do. We got fancy. So we happened to be working with Spark. Spark happened to be extended in 2.3 so that it could use Kubernetes rather than Yarn. So of course we had to be the cool people and use Docker, right? So we got to minutes. And we built a data lake architecture. And we were feeling pretty darn proud of ourselves. We did it using Terraform. But even if like all this jargon is just sort of going over at the end of the conference here, just take a look at the visual complexity of this diagram. It's hard to follow, isn't it? Part of the problem. So I wrote this up. It's all on Medium. The code is open sourced. People have looked at it. They like it. Developers like it. So we said, okay, great, onward. We're going on to the next step because we've passed this on, and now we've built this Medium thing, and we're going to build this Lambda data processor in front of it so that we can evaluate the quality of the data, the size of the data, compress it, partition it, so on and so forth. However, there's one little problem. They didn't use it. And that was really a critical turning point for me because we put hundreds of hours of effort into it. And I pride myself as being able to educate a broad variety of people in how to use cloud technologies. As I said, I have 4 million viewers. So what went wrong? And I have been thinking for many years about this problem of visual complexity, but this particular situation kind of drove me over the top. So about a year ago, I had a time where I was not taking in contract work, and I basically wrote the beginning of a book. And that's actually why I'm here, because I want to continue to work with community and understand how we can improve our visualization of our systems so that we can reduce the outcome that I had here. So the bias here, of course, was our classic bias, but it was represented visually along with every other dimension towards adding complexity. The thinking point is, because I think almost in every talk I've heard this, is to think about it visually rather than just verbally. Because if you train your eye, you can start to see it visually, which can help us address the problem faster. Now, I've been working in tech a really long time. I used to work at Microsoft a long time ago. I had a whole other career building data warehouses, and I wrote 3 books on OLAP cubes, which is an old technology. You probably don't know about it unless you're as old as me. So the thing, though, that is relevant to this talk is because I built a lot of these and optimized them and trained people in the very esoteric MDX language, multidimensional expressions. I was one of like 10 people in the world doing it. It was crazy. I have kind of a lot of experience with complexity through multidimensionality. Granted, it's in the data domain, but I started to think about how I could apply what I had learned there into the visualization of systems architectures. And because I'm in Germany, and because I do speak a little German, I wanted to have a little German quote. So, die Grenzen meiner Sprache bedeuten die Grenzen meiner Welt. Or the limits of my language mean the limits of my world. I specifically came to Germany because I do speak a little German, ein bisschen, and I wanted to be in the sort of mindset of where I had to do something different to communicate, to think about this book. In fact, I'm staying in Germany. I'm speaking some more conferences, and I'm working out of Factory Berlin, co-working there. So if any of you, like after the conference, like don't have time, but you want to like talk to me about this, I'll be in Germany for a month, mostly thinking about this. So anyway, so I was really thinking, okay, we had this failure, like what's missing, like what, from a meta point, like where do we need to be looking? So I just moved to Minneapolis after many years. I moved, oops, go. Is it okay? So what do I need to do? Oh, there, okay, it's okay. Okay, so anyway, so I started, I think it's okay. I'm gonna unplug this. Let's see if that helps. No? Yeah, it's okay? All right, so I started thinking about like, how do we need to depict systems? Are they furniture? I think we've had probably in the conference and just from audience, we know this is not good enough. Are they graphs? How do we translate graphs? There was one talk, French guy was talking about it, was very interesting. I'm kind of a nerd, even though I'm not a university professor. I tend to read like papers just for fun. So again, if you're as into this as I am, so like from machine learning, from geometry, I've been really reading a lot about trying to understand how this visual complexity problem is addressed in other domains. So I think, because I actually have a background in linguistics in terms of dialect, and the insight I've come to is not only in terms of translating human language or translating domain language. This is why I'm so happy to be at DDD, and thank you for letting me speak, is to think about a visual dialect and have a discussion around a visual dialect for our industry. So I've been working in bioinformatics, and I see a lot of art. This is at one of my clients out at MIT. This is a visualization of various disease conditions. And I also use visualizations because I'm trying to learn all this bioinformatics really fast, and the fastest way to learn. So I'm actually going to show this to you. It did have sound, but I'm actually not going to have the sound. Maybe I'll just play it. I don't know. Anyway, so what is really interesting about this is, and I'll only show you like a minute or two. First, it's cool, right? You want to look at it. And it's much more interesting than reading some dry paper about DNA methylation, right? And it has cool sound. So you can see it's like, there, it's eating it, it's working. And you like viscerally understand it, right? It's more pleasurable to learn about these really complex topics. And when I saw this, I thought to myself, well, this is what we need. We need to have a biological basis for our systems. We need to get beyond the mechanical. And I think, maybe to people in the room, this is not a big insight, but it was to me. And I said, okay, this is where we need to go. We need to look at what's happening. And it's like a 10-minute video. There's one more thing that comes and it's going to eat it right here. It's like, ready? It's just going to drop in, and it's good at the end of the conference or something fun, right? It's going to go, and it'll eat it. My slides are already posted, and it's killing it. It's fun, isn't it? Right? So why shouldn't we have fun looking at our distributed systems? Why do we have to look at the architecture diagram and say who the H did this? I can't understand it, right? So anyway, so that was my sort of insight. And then I was like, okay, I want to write a book about this. Well, I want to read a book. There wasn't one, so I will have to write one. And I want to have a community about this. So here I am. So then I really got thinking about a lot of things. And I was like, okay, we need to look beyond our domain, if you will. And so we need to look in areas that are focusing on visualization. We need to do an appropriate translation. By the way, if you haven't gone over to this, everyone knows what this is. Probably from here, this is the Festival of Lights here in Berlin now. It's beautiful. We need to think about how to show movement, growth in a system, death in a system. Growth over time, change over time. It's interesting, as I'm learning bioinformatics, because of the volume of data, there are so many of these great visualizations. And I say, I want this for my, Lambda bursting, my DynamoDB capacity, my, why can't I have this kind of thing? I want something beautiful. Why do we have to produce visualizations of our systems that nobody wants to look at? They should be beautiful. This, by the way, is a wonderful museum here, Architectural Sketching Museum. You can tell I really like Berlin, if you know Berlin. What can we do so we can take sketching and turn it into executable code? And again, this was mentioned in a talk. It was quite interesting to hear. I also am a big fan of Asian art, so showing by not showing. Michael Feathers has a really great blog where he talks about the guarantees form a negative architecture, a set of things that you know can't happen in various pieces of your system. So I would extend that to say, how can we do that visually? And again, because I know I'm going way out there, from tying it back to a practical point, in that IoT project, we had a bunch of consultants coming in all the time, telling us what we should do, what we should do, what we should do. You guys have all had this. And we had this same conversation over and over and over about what we decided not to do and why. So I believe, and this is actually a key part of this talk, in terms of system visualization, the bias that we need to overcome is by not looking outward, particularly to the arts. So if you don't know this guy, you really, really want to look at his work, Brett Victor. He used to work at Apple. He's independent now. He's doing this thing called Dynamic Land. He says, artists draw because they want to convey something they can't describe. And for the purposes of time, I'm actually not going to show you this, but it will be linked. And he has this prototype of a visualization of interactive dynamic system that is basically visually showing calculus. And it is one of the most beautiful, astounding things I've ever seen, and I would so love to see something like this for our distributed systems that was manipulatable and beautiful. So if you're interested, please do watch. All right, so that was my go way out there, but I'm a very practical person. So, you come to my talk, you want to do something now, what should you do? What have I done? How did this work progress? So one of the biggest aspects of working on effective visualization, and this harkens back to when I was working with cubes, is visual dimensionality reduction. Another project that I did is I worked with a company, Here Technologies. You might know them. They're a mapping company, to help them produce reference architectures on the Amazon serverless application repository to get developers up and going. Wrote a series of articles on mediums and created reference architectures and code. So I call this the 3 to 5 aspect architecture. And you might say, oh my God, that's ridiculously oversimple. It's not. It's not. It's really not. It drives adoption. Now you could have multiple views, and maybe in the future we can have drill down views and all kinds of great things. But this point was driven home in a particularly profound way about a project that I care particularly about. You might remember this is the fancy architecture from the Variant Spark project in Australia, the 10 minutes that we were so proud of that the client didn't implement. Did the project stop? Are they just using EMR and they're done? No, they went forward. And this is the architecture they drew. It's kind of embarrassing to see your client do what you didn't. But it worked, so there it is. And what this is an implementation that they put up in the AWS marketplace, which achieved their business goal of making their technology cloud native and more broadly available in a way that was reproducible for them. And I say that this drawing, which when I found, I called them and I said, I am happy you listened to me and I need to take my own advice, was part of the success. So they got it there, and I said, okay, do we stop now? Do we keep going? We want to go multi-cloud. How do we do this? Well, because of this work, I got introduced to the lead architect at one of the biggest genomic sequencing facilities in the world, the Broad Institute at MIT and Harvard. They happen to be on the Google Cloud, and they happen to be one of the biggest users in the world of the Google Cloud. They're putting on average, 17 terabytes per day into the cloud. They have literally broken Google data centers. So I was basically being a fangirl to this guy because I had been studying their implementation, which was at that time called FireCloud on top of the Google Cloud. And he said, you should come. So I did. So the Broad is now my client, which is kind of amazing. So one of the first things that I wanted to do is look at their architecture, and I was so happy to see that basically the architecture of their system that sits on top of the Google Cloud is very similar to what our vision was for Variant Spark's pipeline. It's called Terra.bio. So of course the first question was, can we do it? can we get Variant Spark to work on the Google Cloud in the Broad platform? And the answer is yes. And I think one of the reasons, so this is a notebook running, and the key aspect of this is the dev time was 2 days, is because the CSIRO team had learned effective visualization of architectures. And so they were able to understand and implement, even though it was a different cloud and a different platform, how to get the notebook up and running. It even surprised me, to be honest with you, that they did it in 2 days. And in fact, their success has been replicated. They have now 3 different architectures that are like the very first one that I showed you. They're using Epsagon, a more fancy log reader for what-if scenarios, so that they can perform at a greater scale. And I obviously have to attribute a lot of the success to the fantastic leadership of the team, Dr. Dennis Bauer and the other people in the team there. But my critical takeaway is that this emphasis on visual system representation, and I think maybe because they are biologists and they see technology in service of biology, so they're more open to learning, maybe they're more open to new things, they're able to replicate these architectures and get to business value really almost embarrassingly quickly, more quickly than dedicated dev teams. So what caused that? Yes, they're super talented, but the patterns in the visualization, I think, are key. So this is my practical slide. I always have to have a practical slide. So if you're like, oh, I'm tired, I don't care, whatever she's talking about, I don't know, do this, okay? So there are 5 things, because that's all I get, right? So visualize the entire system. Code, configuration, and data. Use a visual grammar and account for bias. Really think about the bias inherent in the visual grammar. Have an artist look at it. Reduce the dimensionality. Show 3 to 5 aspects max. It's the most difficult one for me. Easy to say, very hard to do. Observe the system state over time. There was one really excellent talk, and they were talking about the design versus the reality. So again, I think this is probably not a new concept, but to show that visually is maybe something new to think about. Verify the object's reproducibility. Aspirationally, I hope that some of you are motivated to what I'm hoping to create as the visual systems documentation community. I gave this talk in Belgrade, Serbia, and I happened to meet a founder of a company called Thundra, who's working on integrated log reading, has a fantastic product. This week in Berlin, there was a serverless talk, and there was a woman from a company called Stackery. Most of these companies are focusing only on Amazon, though, which I think is unfortunate. I really hope aspirationally we can work as a community to make visual open source tools that work with distributed systems, really ideally on-prem or in the cloud. So I said at the end I would say about this image, why it's so significant to this talk. I'm constantly trying to learn more bioinformatics, and so I'm always reading because you know I don't watch television. And so this image is a profound image in the world of biology. It comes from the work of Venki Ramakrishnan and his team and other teams globally. So this is a fantastic book. It is their work for many, many years visualizing the ribosome. And for this work, he and some other people won the Nobel Prize. And so I like to aim high. And so I leave you with the challenge of what will be our picture as an industry? What will be our visualization? I don't think we have Nobel Prizes, but how can we reach this level of focus on visualization so that we can improve the quality of our systems? Now, because I want to be respectful of time, I'm going to end here, but the deck has another section that has more examples of companies that I think are doing cool things. And the deck is already available. It's on slides.com. It's on my Twitter. My Twitter is Lynn Langit. Everything has links. And again, I hope that this can be the beginning of a conversation about this. So thanks for your attention. That's what I have today.